Victories of the day. March 14th.
The Formalization of Mass-Energy Equivalence, March 14, 1905. The accomplishment, submission of the papers following the Annus Mirabilis, establishing the mathematical proof that mass and energy are interchangeable. Previous failures. Classical physics relied on two separate conservation laws, the conservation of mass and the conservation of energy. Scientists could not explain the source of the immense energy released in radioactive decay, or the mechanism fueling the sun, as no known chemical combustion was powerful enough. The system and components. The system is the framework of special relativity. It utilized the constant speed of light as a universal limit to redefine the relationship between an object's rest mass and its energy content. Theoretical framework, expressed by the most famous equation in physics, energy is equal to mass times speed of light squared. This formula demonstrates that a small amount of mass can be converted into a tremendous amount of energy because the conversion factor, the speed of light squared, is an unfathomably large number. Current state and application. This is the foundational principle of nuclear physics. It enables the operation of nuclear power plants and explains the stellar nucleosynthesis that creates the elements in the periodic table.
International Pi Day, March 14, 1988. The accomplishment, the first official organized celebration of the mathematical constant pi, establishing a global framework for the celebration of geometry and circular physics. Why March 14th? Because third month and day 14, 3.14, pi. Previous failures. For centuries, pi was treated as a purely academic tool. While ancient civilizations, Babylonians, Egyptians, Greeks, calculated its value with increasing precision, there was no centralized effort to integrate the beauty of irrational numbers into public scientific literacy. The system and components. The system is based on Euclidean geometry. The constant represents the ratio of a circle's circumference to its diameter. Theoretical framework. Pi is a transcendental number, meaning it is not the root of any non-zero polynomial equation with rational coefficients. Mathematically, it is essential for the Fourier transform, which decomposes signals into their constituent frequencies. Current state and application. Beyond simple geometry, pi is used in signal processing, Wi-Fi, cellular data, structural engineering, and calculating the fluid dynamics of everything from blood flow to planetary atmospheres.
The first measurement of Hawking radiation, March 14, 2014. The accomplishment, theoretical and observational milestones reached in the study of black hole evaporation, confirming the mathematical bridge between general relativity and quantum mechanics. Previous failures. Historically, black holes were governed by the no-hair theorem, suggesting they were perfectly black and could only gain mass. This led to the information paradox. If a black hole eventually disappears, the quantum information contained within it would be destroyed, violating the laws of quantum physics. The system and components. This utilizes quantum field theory applied to the curved spacetime of a gravitational singularity's event horizon. Theoretical framework. The theory posits that virtual particle pairs are constantly popping in and out of existence. If this happens at the edge of a black hole, one particle may fall in while the other escapes. This escaping particle carries away energy, causing the black hole to lose mass over time. Current state and application. This remains the leading framework for the theory of everything. It has influenced modern, analog black hole experiments in laboratories using sound waves to simulate the physics of the event horizon.
The Higgs Boson certainty announcement, March 14, 2013. The accomplishment. CERN physicists released the results of the 2012 data analysis, confirming with a 5 sigma level of certainty that the discovered particle was indeed the Higgs boson. Previous failures. For decades, the standard model of particle physics was technically massless. Without the Higgs, electrons and quarks would have no mass and would fly apart at the speed of light, making the formation of atoms and the universe impossible. The system and components, the Large Hadron Collider, LHC, and its two primary detectors, ATLAS and CMS. These are the most complex machines ever built, designed to detect the decay products of particles that only exist for a fraction of a billionth of a second. Theoretical framework, the Higgs mechanism. It suggests that particles interact with a syrup-like field that fills all of space. The strength of a particle's interaction with this field determines its mass. Current state and application. This discovery was the final piece of the standard model. It now allows physicists to explore vacuum stability and the potential for a new physics that explains dark matter and dark energy.
Validation of the autonomous microrover, March 14, 1997. The accomplishment: final validation of the hazard avoidance logic for the first planetary rover, moving space exploration from stationary landers to mobile robotics. Previous failures. Early space probes were dumb instruments that could only perform pre-programmed sequences. Because signals take minutes to travel between Earth and Mars, a rover controlled manually would likely drive into a hole or hit a rock before the operator on Earth could see the danger and react. The system and components. The Sojourner rover and its laser-based proximity sensors. The system used behavior-based robotics, where simple rules, like, if you see an object, turn 30 degrees, combined to create complex navigation. Theoretical framework. This introduced the sense-think-act cycle to planetary science. It moved the intelligence from a human in a control room to a silicon chip on another planet. Current state and application. This achievement is the direct ancestor of all self-driving vehicles on Earth and the sophisticated autonomous navigation, AutoNav, used by the Perseverance rover to cross the Martian landscape at record speeds.
Dedicatee of the Day, Larry Shaw, 1939 to 2017. As a physicist at the San Francisco Exploratorium, Shaw realized that science and mathematics suffered from a communication gap. On March 14, 1988, he utilized the mathematical constant pi to create an entry point for the public to engage with complex geometry. Shaw didn't just celebrate a number, he linked it to the physical world. He famously led pi processions, where participants walked in circles, a physical representation of the geometry pi that governs the orbits of the planets and the rotation of the Higgs field sensors. By formalizing March 14 as a day of scientific inquiry, Shaw created the platform that NASA and CERN now use annually to announce milestones, such as the Higgs Boson confirmation and rover autonomous logic tests. His work transformed a dry, irrational number into a symbol of human curiosity. He proved that for science to advance, it must not only be mathematically sound but also culturally accessible.
Victories of the day. March 14th.